This is a STM32 F4 Discovery board, and in this board we have a microcontroller which is STM32 F407, as you can see on this packaging. I will open this box and you will be able to see what's inside. However, I would like to share with you a bit of information about what we're going to do. STM32 F4 07 is an ARM Cortex microcontroller or Cortex M based product. It's a microcontroller from ST Microelectronics, and the board you're seeing is a discovery board which we can use for building software and experimenting with the hardware. This is obviously a dev kit, a development kit. Is used for evaluation of the microcontroller, and in a real project a hardware designer would pick up the microcontroller from ST Microelectronics and would design a new PCB. What I would like to suggest us starting with is having a quick look at this processor, this chipset. This microcontroller includes, if you pay a bit more attention, actually, you will be able to see on this board that this is a VGT6 model. You can see it's written there in that part, and the VG is listed here as one of the 1 megabyte flash sized microcontrollers. As you can see, this is the VG model listed with 1 megabytes of flash size. This means when we build a program and we want to flash it permanently to this microcontroller for the hardware and for the experimentation to remain, even when we unplug the power from the board, we will have 1 megabyte of space to play with. In terms of exactly which ARM CPU or ARM processor this board has, you're able to see here on this page that we have a Cortex M4 core, and Cortex M4 is a product from ARM, the British company that develops the microcontroller architecture. Cortex M4, here you can see the kind of high level aspects are listed. There are of course some details that change from version to version, but all Cortex ARM Cortex M4 microcontrollers or processors actually have these features. The DSP, the FPU, the floating point unit, the architecture is based on ARM v7M architecture. So the assembly instruction sets that you can write are defined by this ARM v7M, and you can see there are quite a few other parts of this processor, including JTAG, which is a hardware debug protocol used for debugging and basically testing parts of the hardware and debugging the software that you're writing for this microcontroller. Some other details are provided on the ARM website, as you can see. ARM v7EM, it comes with thumb and thumb 2 instruction sets, and the DSP extension, it gives you digital signal processing capabilities, including 8 and 16-bit parallel processing instructions. SIMD instructions, if you're familiar with them. We have debug, as I said, JTAG and serial wire debug. These are 2 ports provided for your specific development boards. We do have a debug unit built into this board. This part of the board that you can see is the main microcontroller part, but here at the top you can see we have a few other bits added which actually provide type of ST Microelectronics specific debug methods. So you don't need a third-party tool or an external debug tool to interface with your development environment as you create the software. So going back to ST Microelectronic website, they are listing the performance to be at 160 megahertz, and let's see what else we can find. There are two USB on the go interfaces on this microcontroller. USB on the go, or OTG, means the microcontroller has the capability of switching between a slave or a host mode, as in being something that's plugged into a host, or being the host that can accept USB devices plugged into it. So we have two of those USB types. There are your usual communication systems here, and some analog features, 12-bit digital to analog converters, 12-bit analog to digital converters, and you can see that there are a bunch of other features available. So the 32F here in the naming, it refers to having the floating point unit available, which can be useful for certain types of digital signal processing algorithms and applications, or DSP applications. I think this gives you a good overall highlight of what this board is. Our aim, however, today is running ZephyrOS on STM32 microcontrollers. So ZephyrOS provides out of box. The team is providing a number of boards supported by this project. I think if I go to the supported development kits with STM32, you can see that Discovery, STM32 F4 Discovery is one of them. I can remove STM32 from my search and actually have a look at the supported boards page. This is a good starting point if you're wondering whether ZephyrOS is supporting your particular board or development kit out of box. So if I search for STM32 F407, I'm not finding it. However, I think the STM32 Discovery might be listed. There are a lot of Discovery boards here. So we have F4 Discovery. This is the most generic one that I can find. Let's see, F4 Discovery. I'm guessing our specific F4 Discovery board is also included. So let's go in there and check out. Yes, so as you can see, this is exactly the board that we have, and fortunately ZephyrOS project is supporting this board out of box. As you can see, the following hardware components. So this is specific to the VGT model. As I said, we have a VG model, which is great because this is a good match. We do have the extra letters at the end here, which is the T6, but that's a very specific narrowing down of the board. So I can guarantee that actually our board is supported by ZephyrOS project. As you can see, as we discussed already, this is a Cortex M4 CPU with floating point unit. It's running at 160 MHz max CPU frequency as listed on the ST website itself. We have 168 MHz and 168 MHz. They match, which is important if you're running an operating system on your kit. You have to make sure that the expected frequency of the CPU matches your actual real hardware. And you can see a lot of other features of this particular board is listed on the ZephyrOS project website, and that's a good sign. It means that the operating system, the real-time operating system, actually supports all of these features, and you can take advantage of this operating system to drive your kit. So our challenge today is finding out how we can run the ZephyrOS on this development kit. I hope that you've enjoyed this video, and I'm looking forward to continuing this in the next video.